Hi guys, today we're going to learn about integration by parts. Integration by parts is used to integrate a product such as the product of an algebraic expression and a transcendental function. Something like integral of x e to the x dx, integral of x sine of x dx, integral of x natural log of x dx, etc. As you can see, if you would do the u substitution here, which it would be x, the du it would be 1, so you have extra information or extra stuff here. That's how you can tell that you need to use integration by parts. First, let's go and understand where the formula comes from. So if you remember the product rule, if we have the derivative with respect to x of u times v, what we have is that the derivative is going to be u dv dx plus v du dx. Okay? So if we integrate both sides, what you're going to have is that uv is going to be equal to, technically speaking, the integral of uv dx plus the integral of v du dx. On this side, technically speaking, you would have d dx integral of uv dx, which by second fundamental theorem of calculus, it would cancel. Now, what we're going to do is we are going to rearrange and solve for the integral of uv dx. Please note something, this cancels. So what you rearrange here is you have that uv is going to be equal to the integral of u dv plus the integral of v du. Okay, so the formula for integration by parts is pretty simple because we're going to solve it for this one. So you have that the formula for the integration by parts is going to be the integral of u dv is going to be equal to u times v minus the integral of v du. Okay, so this is the formula for the integration by parts. How in the world I remember this formula? Well, if you know, I learned calculus in Spanish. So this is how I remember this. Let me zoom out so you can see it. Okay, so what you see is the integral of u dv, un día vi, uv, una vaca vestida de uniforme. So that's how I remember. I always, in my brain, I always see that cow with a uniform. Okay, so doesn't matter where, when, how, and I always remember my integration by parts formula. Hopefully it also works with you. Okay, so going back to our notes. Okay, so let's go back to our notes. You can see here that we need the integration by parts formula because you have an x times the e to the 3x dx. Now you're going to tell me, how in the world I'm going to know what's u and what's dv? Okay, because what you're going to see here is this part. Okay, so here's the list, the priority list that we're going to use. Okay, so your u is going to be the one that you need to decide what's that. Okay, so you're going to use this. Okay, the L is going to be log or natural log functions. I is going to be inverse trig. Okay, A is algebraic functions, aka polynomials, trig equations, and then the last one is exponentials. So your priority is, if you see a log, that's going to be your first selection of u. If you see inverse trig, that's going to be the second highest. The third highest is algebraic expression, then trig, and then exponential. Okay, so remember that. Okay, so you can we can write it here. So you remember that that's our code for the priority list of u's. Okay, so you see this. What are you going to do? According to the priority list, you have an algebraic function and an exponential expression. So your u is going to be the algebraic because this is in higher. Okay, the algebraic expression. So u is going to be x. Your dv is going to be e 3x dx. Okay, so we need, technically speaking, we need 4 pieces of the puzzle. The second piece, the third piece that we need, because we have 2, is the derivative of u, that we can get it. Okay, so that's going to be dx. And then here we want to find v. The way to find v is the integral of e to the 3x dx, which we know that it's going to be 1/3 e to the 3x. Do you agree with that? So with that, we're going to apply the formula. The formula tells you u times v, so x times 1/3 of e to the 3x. Okay, so you have this, okay, minus the integral of v du. Okay, so you have that it's 1/3 e to the 3x dx. So you're going to tell me, how in the world you're telling me that this formula is going to work if it gives me another integral? The cool thing about this is that this integral, it's easier to integrate than this one. As you can see, this one, pretty much we can do a mental u sub, okay? So you have that this is going to be a u sub, this one we keep it the same, so just copy that one. Then that one is going to be a u sub, which is going to be 1 over 9 e to the 3x plus c, and that's it, okay? Why? Because your u in your brain, what do you think is u is equal to 3x, du is equal to 3dx, okay? You are missing that 3, so you divide both sides by 3, and the 3 that we have here, that's the 9 that you see here, okay? Isn't that cool? Okay, so another method that is very popular when you are doing integration by parts is what we call the tabular method. Okay, the tabular method, you can see that here again you select, you can see that it's going to be by parts. Your u would be the polynomial function. Okay, so since my polynomial function is degree 2 or more, and then I have another function that it's an exponential that it's lower than the algebraic, in this case exponential, what we're going to do is we're going to do a table. Look at this. Okay, so we have the sign, then we're going to have the u, and you're going to have the dv. Okay, you're always going to start with the sign positive. Your u is going to be the x squared, and then the dv is going to be e to the 3x. Okay, so what we're going to do here, and let me here separate everything so it doesn't look weird. What you're going to do here is we're going to alternate sign here, and then we're going to take the derivative of this until we get to 0, and then here you're going to take the integral. Okay, so you start minus the derivative of x squared is going to be 2x, the integral of e to the 3x is going to be 1/3 e to the 3x. Then you have that this is plus, we haven't finished because the derivative of 2x is 2, then the integral of that thing is going to be 1 over 9 e to the 3x. Then you go ahead another step, minus, then you get the 0, meaning we're almost done. Take the, we're on the last step, pretty much this is telling you that you're in the last step. Then you have 1 over 27, e to the 3x is going to be the integral of this. So what are we going to do here? What I recommend you to do is you multiply this part, okay, and keep adding every bubble, okay? So you are going to have this and this, meaning what you're going to do here is you are doing integration by parts multiple times, okay? Specifically in this example, we're going to do it 2 times, okay? If you do it by parts, okay? So plus, and then you have that's a 2 divided by 27 e to the 3x plus c. Okay, so you can see that this term is going to be this bubble, the second term is going to be this bubble over here, and the third term is this one that it's the bubble that you have here. This is the tabular method, okay? So the name is the tabular method that, technically speaking, is doing integration by parts more than once, okay? In this case, we're doing it twice, okay? And the tabular method, I recommend you to do the tabular method when you have the u as a polynomial degree 2 or more, and then the dv could be a trig function or an exponential, okay? Otherwise, I would recommend you to do integration by parts, okay? So for this problem, what you see is that you have the integral of x power 3 natural log of x dx. The first thing that you need to remember is you have your priority list here. So the log is very, very high, okay? So your u is going to be the natural log of x, okay? dv is going to be x cubed dx, okay? So you know that the derivative of natural log of x is going to be what? It's going to be 1 over x dx, and the integral of x cubed dx is going to be what? It's going to be x power 4 divided by 4, okay? So now you have your uv, okay? So I'm going to call it star, and I'm going to rewrite it here, okay? So you can see it here. Okay, so you have this times this, so you have x power 4 divided by 4 natural log of x. Then you have the negative, the integral of v du, okay? So this too, so let's do it, okay? So you have this times this, okay? After that, you can cancel this term, so you have x power 4 divided by 4 natural log of x, and then you have minus, you have, what do you have there? 1 over 4, okay? And then you have the integral, right? Okay? Of x power 3 dx, okay? So you have this equation, which is very simple to integrate that last term that we have over there. So you have x power 4 divided by 4 natural log of x, and then you have that this is going to be what? It's going to be negative x power 4 divided by 4 times 4 is 16 plus c, and that's going to be it for this problem. Isn't that super nice? So if you have limits of integration, first you're going to integrate as if you didn't have the limits. Okay, so what you're going to do here, you have your same priority list. Remember, we have Lie8. Okay, so your according to this priority, your algebraic expression, which is going to be x, that's going to be your u. So you have u is equal to x, then you have that dv is going to be your sine of x dx. So after that, you have that your du is going to be just dx or 1 dx, and the v is going to be negative cosine x. Do you agree with that? So once you have that, you are going to do uv, okay, so negative x cosine x minus the integral of v du. Okay, so this one is a negative, so negative and negative makes positive this one. So technically speaking, you have a cosine x dx. Okay, so what you have is you're going to have that this is going to be evaluated from 0 to pi over 2 over here, 0 to pi over 2 over here. So leave it as standby. Okay, so I would put it like this. Okay, 0 to pi over 2, and then that one, we know that when we integrate the integral of cosine of x dx, you know that that one is going to be plus, right? That was a plus sine of x, and you're going to evaluate that from 0 to pi over 2. Happy? Okay, so what you have is that when you plug the pi over 2, you're going to have 2 zeros here, so minus 0, 0, plus, and this is going to be 1 minus 0. So you have that your result is going to be the beautiful one. Do you see it there? Okay, so you can plug it here and get the zeros there, and then you're going to get the same thing. So as long as you respect the first fundamental theorem of calculus, you're good to go. Okay, so let's move on to one example that comes from an old AP test. Okay, so here you have the integral of x sine of 6x dx. So this one, again, your priority list, remember that you have the algebraic on top of the trigonometric, so u is going to be x, and your dv is going to be sine of 6x dx. Okay, so what you have is that you have that du is going to be 1 dx or just dx, whatever, and v is going to be what? It's going to be negative 1 over 6 cosine of 6x. Okay, so what you do is this times this, so you can see that it's negative x divided by 6 cosine of 6x, and then you have minus, right? The integral of v du, this times this, so the minus and minus, it becomes a plus, so you can put the 1 over 6 here, and then you have the cosine of 6x, and you have your dx. Okay, so over here at this point, you are like, I can already eliminate a bunch of answers. This one is wrong, this one is wrong, and this one is wrong. You see it? So because the first term is not correct. This, the student forgot the negative there. Okay, so over here you will recognize that both of them, they are good candidates, but what's the difference here? When you have the integral of this, you know the integral of cosine of 6x is going to be 1 over 6 sine over 6x. So 1 over 6 times 1 over 6 is going to be 1 over 36, and you have that that's going to be your answer. Okay, so you can actually don't even finish it, and you can already know that it's B. Okay, because this one, the student forgot to do the u solve there, or forgot to put the 1 6 when they were multiplying distances. Okay, so you can see that it's a really good strategy there. Okay, another example that we have here, that it's AP, an old AP question here. You have this table, right? This table gives you values of f prime of x, g prime of x for selected values of x. If you have that the integral from 0 to 1 of f prime of x times g of x dx is equal to 5, then they are asking you to find the integral from 0 to 1 of f of x times g prime of x dx. So what are you going to do here? This one is screaming integration by parts. Okay, moreover, what you recognize here is you recognize that u is going to be f of x, okay, and your dv is going to be equal to g prime of x dx. So what you have is that the derivative of u is going to be f prime of x. You know that it exists for those values because you have them here. Okay, and then you have that b is going to be by second fundamental theorem of calculus. You know that this is going to be g of x. Okay, so it's pretty nice. Okay, so you can do the formula uv. Okay, so you have f of x times g of x, and this is going to be evaluated from 0 to 1 minus, and you have that it's going to be the integral from 0 to 1 of what? This one times this one. So you have that it's going to be g of x times f prime of x dx. And guess what? Do you know the value of this? Oh wow, isn't that 5? Okay, so I'm going to call this star, Okay, and I'm going to continue for you. So you have that for first fundamental theorem of calculus, you have that f of 1 times g of 1 minus f of 0, g of 0, okay? So that's going to be your first term, and then minus 5, right? So then you go ahead and you look at your table, your f of 1 is 4, okay? Then you have that g of 1 is going to be 3 minus, and then you have that it's going to be f of 0, which is 2, and then you have that it's g of 0, which is negative 4, okay? And then minus 5, so you have that this is going to be 12 plus 8 minus 5, that's 15. And guess what? That value, okay, so that's 15. That value is part number E, okay? And that's pretty much for this part, okay? I hope that you find this video helpful. Bye!